The calculation of indoor salt pressure level can be used to predict or test the effect of acoustic design to determine whether the arrangement of receiving points or the shape and size of the room are appropriate, and whether the design goal can be achieved. For electroacoustic systems, it can also be used to calculate the power of speakers. This is a formula for calculating the steady-state salt pressure level of a point salt source propagating in a room. The formula ignores the absorption of air. The directivity factor of a non-directional point salt source is equal to 1 when it is in a complete free space, and it is equivalent to half a free space when it is attached to a wall or ceiling. From the calculation formula of indoor steady-state salt pressure level, it can be seen that the indoor salt energy density includes two parts, direct salt and reflected salt. The direct salt follows the inverse square law of distance, and the reflected salt depends on the indoor salt absorption condition. There are three situations in which the direct salt is greater than the diffuse salt, equal to the diffuse salt, and less than the diffuse salt. The first and third situations correspond to being closer and farther from the salt source respectively. The second case corresponds to the equal salt energy density of the direct salt and the diffuse salt, and the distance from the salt source is called the revolution radius, or the critical radius. It can be seen from this side. The larger the room constant, the greater the indoor salt absorption and the longer the revolution radius. Therefore, the comparison between the distance between the receiving point and the salt source and the revolution radius can be used to judge whether the noise reduction by absorption method can be used. When the receiving point is within the revolution radius, the direct salt is mainly received, and the effect of noise reduction by absorption is poor. When the receiving point is outside the revolution radius, it mainly receives diffused salt, and the effect of noise reduction by absorption is obvious. The language-based room requires high clarity and requires strong direct salt, and the speaker can be selected with a larger directivity factor. Next, let's do an exercise. It is known that the volume of an auditorium is 20,000 cubic meters. The total indoor surface area is 6,257 square meters. The average salt absorption coefficient at 500 Hz is 0.232, and the salt power of the actor is 340 microwatt, and the salt is produced on the stage. Find the salt pressure level of the last row of spectator seat and the revolution radius. Ignore the directivity of the human voice. The stage is a complete free salt field, and the directivity factor is 1. Using the indoor surface area and the average salt absorption coefficient, the room constant can be obtained as 1890. The unit of salt power of the salt source is microwatt, which needs to be converted into watt. Using the formula of indoor steady-state salt pressure level, the salt pressure level at a distance of 39 meters from the salt source is 58.8 decibel. Using the calculation formula of the revolution radius, the revolution radius is equal to 6.09 meters. It can be seen from this side. The spectator seat is in an area where diffuse salt is dominant, and the noise reduction by absorption method can be used. Can you try to calculate the salt pressure level of the front row? Comparing the salt pressure levels at the front and the rear positions, you can also think about how to reduce this measured pressure level diffuse. If there are receiving points before and after the revolution radius, how to reduce the noise of the front receiving points. The process of salt growth, steady state, and attenuation is based on the diffuse salt field, which is analyzed from the perspective of energy. It is considered that the salt energy density in the room is uniformly distributed, and the fluctuation and frequency of the salt are not involved. But in fact, the indoor salt energy density will be strong or weak, depending on the frequency of the thought source. When the frequency of the thought source is close to the resonant frequency of the room, it is easy to cause the room to resonate, and the thought energy density of the resonant frequency is also enhanced. Axial resonance occurs in a one-dimensional space between two parallel walls, and the resonance frequency depends on the distance between the walls and a series of positive integers. As can be seen from the formula for the actual resonance frequency, the larger the L, the lower the minimum resonance frequency, as long as the distance between three pairs of parallel walls in a rectangular room is an integral multiple of half wavelength. Actual resonance in the corresponding direction will occur. Tangential resonance occurs in two-dimensional space. Oblique resonance occurs in three-dimensional space. It can be seen from the calculation formula of the oblique resonance frequency that the oblique resonance frequency includes the tangential and axial resonance frequencies. It can also be seen that the size of the room has a strong effect on the resonant frequency. This picture shows a rectangular room with three scales. Picture A has the same length, width, and height. Picture B has the same length and width, and picture C has unequal length, width, and height. Each vertical line in the figure represents a resonance frequency, and the symbol lambda indicates the same resonance frequency. As can be seen from the figure, there is an overlap of resonance frequencies. The phenomenon of overlapping resonant frequencies is called the generation of resonant frequencies. The generation will greatly enhance the thought equivalent to the resonant frequency, resulting in thought distortion, frequency distortion, and thought color. The principle to prevent the generation is to make the resonant frequency distribution as uniform as possible. Specific measures include 1. Choose the right size and shape of the room and avoid the room with the same three scales. 2. Make the wall or cells of the room into an irregular shape. 3. Distribute the thought-absorbing material irregularly on the interface of the room. You can use the calculation formula of resonance frequency to check whether there is the generation in the surrounding rooms, and check whether there is a possibility of the generation in your architectural design work.